using this very, very inexpensive platform, we have taken the platform to its limits. We have developed a huge range of experiments to provide students an experience which they lacked before. So these days at the university in Nigeria, in Uganda, we have the Elvis Island integrated into the curriculum. Not only this, but this has provided research opportunities for students. The people who are actually making the functionalities in Tanzania, in Uganda, at MIT are actually graduate students and undergraduates, some of the time. And they have this interesting project to work on because the iLab combines a lot of different technologies. It has hardware components. So it's a really interesting project and it has led to some really interesting business work. And with that, there have been collaboration because these students, there have been constant faculty and student exchanges. We have gone to Dar es Salaam, students have come to us, and this has led to discussions on remote laboratories, on engineering education. It has really led to this one global engineering project. And also with the discussions, with the experiences in UDSF and in Tanzania, in Nigeria, people have developed other labs that are just not only iLabs, so not only Elvis based. So yeah. Moving forward, we need to integrate the Elvis 2 more. So right now, most of the labs use Elvis 1, so we need to integrate the Elvis 2, develop more intuitive interfaces where people can configure hardware, connect the wires. Also, the African universities, the partners are, we want to help them serve as hubs to disseminate iLabs to other universities within the country. So that we are supporting. And also, one of the main challenges is retention of faculty. So these graduate students who develop iLabs, who develop the functionality, once they graduate, they leave the university and take the experience, knowledge with them. So in the next phase of iLabs, this is going to be one of the most important topics. Alright, thank you. I'll take any questions.
Yeah, describe briefly how you use the computer control switch to select your circuit.
Sure.
That seems to be the hardest part.
Alright, so this one right here. So we have, in this diagram, you can see that the student has a choice of resistor. So he clicks on one of the nodes and he can pick, okay, what resistor value he wants at that node. So, and what happens is that when he said, okay, I want, let's say, a 3K resistor, a 3.2K resistor, you'd have switches in the real hardware that would throw and connect that specific resistor.
Are they limited to particular structures, so you have to plug a resistor here, a capacitor
Yes.
there?
For now, and that's the next bit. That's the next plan. We're hoping that to make it more reconcilable. But now, yes, you have a resistor, so you can choose what value you want. But the OAU one, they have an interesting open experiment where you can actually wire stuff. So the one on the right, you can actually connect components using just a mouse click, and they will say, okay, is this configuration correct? Will it break it? If it's correct, then it will allow students to actually run the experiment. So yeah.
Coming back to what you mentioned right now, what happens if the student plug a resistor which is not available as a real hardware? Of course, I think there's a constraint of resistors for this specific case. Like
Right.
So any help to say, well, these are the constraints, and you have to think very carefully which one you would choose.
Yeah. So right now the range, the options are limited. See, we have a drop-down list. So the students can only choose the values that are available. But that's also once we have a more configurable plan, that would be something that we can look at. Maybe have a potentiometer that a student can adjust, things like that.
Okay.
How many students can use the lab at the same time?
Excuse me?
How many students can use the lab?
Okay, so this is an interesting. So these experiments are batch experiments. So what happens is that the student says, okay, I want to run a sine wave with this frequency, this amplitude, and I want to sample it at this rate. And he submits the experiment. The experiments are queued up. It's not, you don't actually interact with the hardware in the Elvis experiment. You actually send the experiment which are serviced in a first in, first out queue. So basically, they're all queued up and you get a time. Okay, you are number 6 in the queue, for example, things like that.
Do you have any booking system? No.
Excuse me?
Booking system.
Yes, so this is a batch version where you send out experiments in a batch, so you put your results and you send it out, or your specification and send it out. But there's another version called interactive where